Hi everyone, it's Mrs. Summer here to talk about Lesson 601, Graphing Systems of Equations. Just a heads up, Systems of Equations is like one of my favorite units to teach in math. So I'm hoping you guys get excited about it, but I'm excited that we're doing Systems of Equations. So in this unit, or this lesson, students will be able to define a system of equations, graph a system of equations, and determine the intersection point of the system. So some key vocabulary. A system of equations is a set of equations that are graphed together on the same graph. It's an intersection point, the point on the graph where the two equations intersect. This is the solution to the system. The answers must be written as a coordinate pair unless it's a word problem. So think about something in life, which you probably haven't used since COVID started, but air traffic controllers use systems of equations on their computers and everything to make sure your planes don't intersect. That is like one big reason, like big application, real world application of systems of equations. So to graph a systems of equations, here's a question. It says graph the following system: 2x minus y equals 2 and 2x plus y equals 6. So step 1, make sure your equations are in slope-intercept form. So I rearranged my equations and I got y is equal to 2x minus 2 and y is equal to negative 2x plus 6. Step 2 is to graph each equation on the same graph. So that is what I did over here. Let me get rid of this. So I graphed them on the same graph. Step 3 is determine which coordinate point the two points where the two lines intersect. This is your answer. So if we look here, the two lines intersect at 2, 2. So, and then step 4 is to write your answer as an XY coordinate point. So my answer would be written as 2, 2. On your mastery checks for this lesson, for all of the lessons, when you have to write a coordinate point, you have to include the parentheses on either side and no spaces. Here's one where you try. Solve the following system by graphing. Write your answer as a coordinate point. So for this, step 1 would be to rewrite the equations into slope-intercept form. So the top equation rearranges into y equals 4/3 x minus 4. The bottom equation rearranges to y is equal to 2/3 x minus 6. Then we need to graph the two equations on the same coordinate point, or on the same graph. And then we need to determine where they intersect. They intersect here, which is at, -8, -3. So we write our answer as a coordinate point. -8, I wrote that wrong. It is -3 and -8. So -3, because x comes first, -8. Before we begin the graphing word problems, you guys can pause, throw a mini temper tantrum, let it all out, groan, whatever you need to do to get in the right mind space to do word problems. Okay? Are you there? Good. Solve the following system word problem by graphing. Kendra owns a restaurant. She charges $3 for 2 eggs and 1 piece of toast, and $2 for 1 egg and 1 piece of toast. How much does Kendra charge for an egg? How much for a piece of toast? So, step 1 to word problems. Every single word problem is we write what we know. So in this question, in the problem, we have she charges $3 for 2 eggs and 1 piece of toast. She charges $2 for 1 egg and 1 piece of toast. So that is what we know. We know 2 times the price of the egg plus 1 times the price of the toast is $3. We also know that 1 times the price of the egg plus 1 times the piece of toast is $2. The next step is to define your variables. So I define my first x as my price of an egg. So price of an egg is equal to x. So my price of toast is my y. Step 3 is rewrite what you know in terms of x and y. So I just took what I wrote up here and put it in terms of x and y. I didn't change anything else. So my first equation is 2x plus y is equal to 3. And then my second one is x plus y equals 2. Step 4 is to rearrange the equations to be in the form you can graph. So when I do that, I get y is equal to negative 2x plus 3 for my first equation, and y is equal to negative x plus 2 for my second equation. My step 5 is to graph my equations. And that's what I did over here. And where they intersect is at 1, 1. So find where they intersect. I found that they intersect at 1, 1. Then step 6, this is very, very important. Answer the questions being asked. So what were they asking? They were asking, how much does she charge for an egg and for a piece of toast? So what we said was, the cost of one egg is the x in our xy coordinate point. The cost of one egg is $1. The cost of one piece of toast is the y in our coordinate point, and the cost of one piece of toast is $1. Now you try. Solve the following system word problem by graphing. So first, step 1 is write what we know. Okay, we know in this question that a cake costs $10 and a pie costs $12. And we also know that the store sold 8 baked goods for a total of $84. So how many cakes did they sell? So write what we know. We know that $10 times the number of cakes plus $12 times the number of pies equals 84. We also know that the number of cakes plus the number of pies is equal to 8, because they only sell 2 kinds of baked goods. The next step is to define our variables. So I defined it, let x equal number of cakes sold. I defined my y as number of pies sold. Then I need to rewrite what I know in terms of x and y. So I have 10x plus 12y equals 84. X plus y equals 8. Step 4 is to rearrange the equations to be in a form you can graph. So these equations are already in standard form. You can find the x and y intercepts for each equation and graph, or you can rearrange into slope-intercept and graph. So I rearranged into slope-intercept, and I got y is equal to negative 5, 6, x plus 7, and y is equal to negative x plus 8. So my step 5 was to graph the equations. I graphed them over here, and my intersection point is right here, and my intersection point is at 6, comma